Hi, welcome to the screencast designed to orient you to the adaptive branch of the immune system. During our last class, we looked at the innate branch. We're going to ignore that now and focus just on the components of the adaptive system, which are represented on this diagram in blue. With the innate system, you read and probably saw in the videos that it doesn't recognize specific pathogens in the body. If it sees something that looks sketchy or foreign, it responds to it without really knowing what it is. The adaptive system is very different. It is capable of recognizing different disease-causing organisms, and it uses specific cells to respond to each. Thus, one of the first ways that it differs from the innate system is in its ability to be very specific. It recognizes and responds to pathogens that it specifically knows. It can tell the difference between chickenpox virus and human papillomavirus, for example. Another way that it differs from the innate system is it is systemic. This means that when it becomes activated, cells throughout the entire body, the entire system, are activated. The whole body responds instead of just having the immune response restricted to a small area, like we see with inflammation, for example. Here's one last way that the adaptive system is different from the innate, and this might be the coolest difference because it saves us from getting sick over and over again with the same thing. The adaptive system recognizes viruses, bacteria, and other pathogens that it has seen before, and if they invade the body a second or third or fourth or any number of additional times, the adaptive system remembers them and completely obliterates them from existence within hours. So this system has memory. It's like the bouncer at the bar that has kicked you out once before for being a troublemaker, and after that remembers you forever, even decades later, and you never get a second chance to get in and cause trouble again. This is, by the way, why you don't get chickenpox twice and why vaccines work to prevent disease. We'll be really focusing on this part of the adaptive system, its memory, in the next few class periods. As you focus on this diagram of the adaptive system, you'll notice that right off the bat it has two branches. The humoral branch responds to pathogens that are floating around in body fluids, things like blood and lymph. That is where this branch got its name, because humors was an old term for body fluids. However, as you learned in our last class period, some microorganisms like viruses are capable of doing something much more freakish than just floating around in your blood or lymph. They can actually get into your cells and take them over, turn them into a virus factory, and then essentially use your cell as a battle base against you. For that type of situation, when the microorganism is hunkered down in your own cell, we need the cell-mediated branch to destroy the cell that's housing the microorganism and thereby take away its battle base. There are three major cell types in the adaptive system: B cells or B lymphocytes, T cells or T lymphocytes, and antigen-presenting cells. If you look at the organization of the adaptive system, you'll notice that B cells are the major players in humoral immunity. When they encounter foreign pathogens in the body, they initiate a chain of events that leads to the production of antibodies specific for destroying the invading pathogen. Antibodies are just protein molecules that can inactivate or neutralize a pathogen. You'll learn more about them in an upcoming assignment. Over in cell-mediated immunity, you'll notice the major players are a couple different types of T cells. Helper T cells are responsible for coordinating the entire immune response, cell-mediated, humoral, and innate. Thus, they are indispensable, and you'll learn more about why as we continue in this system. They are, by the way, the specific cells targeted for destruction by HIV, and that is why HIV takes down the entire immune response, because it goes straight after the generals, or the cells that are coordinating all of immunity. Cytotoxic T cells are the ground troops, or the foot soldiers. They take orders from helper T cells and are the cells within the cell-mediated branch that actually go out and destroy microorganisms. Lastly, antigen-presenting cells, or APCs, are the spies, or the policemen of the immune system. They look for foreign invaders in the body, and after finding them, take them and show them to a helper T cell to get an immune response against that pathogen coordinated. I should say that B cells can act as APCs, so there is communication between both branches of adaptive immunity. They work together at the same time and also work together with innate immunity through coordination of the helper T cells to defend our body from pathogens. This concludes the screencast overview of adaptive immunity.